My name is Nikola, and my pointer doesn't work. Oh, it works better once it's on. Yeah, I've been dabbling around web-related stuff and web applications for quite a while now, close to 15 years, a significant chunk of which professionally. And I work at a company called TVBeat, where we do TV audience measurement solutions and advertising solutions based on census data. And at TVBeat, my primary concern are applications that at some point end up speaking the hypertext transfer protocol. And as we all know, where there's HTTP, there's bound to be a web server. Now, if you're like me until a few years ago, once your web server is up and running, you didn't give much thought about it. You may have written a few neat configuration files, maybe you've even tacked on a few modules, but once it's there, you consider it this fairly stable black box that somehow takes incoming HTTP requests and translates them into something your web application can understand, and that's it. Unless you're in ops, in which case I salute you, brave folks. But for developers, that's a fairly standard approach to web servers. And I do hope that one of the key takeaways that I will offer to you today as a result of this talk is that the web server can be used to do much, much more than just that. A prime example of a web server is Nginx. Nginx was built in 1999 in order to tackle the C10K problem, which boils down to handling 10,000 concurrent TCP IP connections on a single machine. Now, that may or may not look trivial to you from the standpoint of 2019, but in 1999, that was far less of a stroll than it is today. Today, Nginx powers between 30 and 40% of the public internet, with a few caveats. And if your small corner of the public internet is not within those 30 to 40%, bummer, because this talk will be mostly dealing with Nginx. But I do hope that it will convince you to reconsider it, or at least give it a shot for your next deployment. So there are two very important things about Nginx that will be relevant to this talk. The first one is that it has a modular architecture. So Nginx exposes an API that can be used to build modules to augment the functionality that it provides. And the second thing is that it's built on an asynchronous event-driven architecture. And this is a fairly important part that we'll get back to repeatedly during the lecture. And this is one of the things that originally enabled Nginx to tackle the C10K problem. So the modularity part is really important. And Nginx has modules for plenty of things that you would expect to do in a web app. You can query your databases, you can query your in-memory data stores, you can authenticate on LDAP, you can parse JSON, most of the things that you would expect to do. However, the problem with these modules is that they are mostly configured using the Nginx configuration language. Now, this is really neat if you only need to map a single HTTP endpoint to an SQL query and return it as JSON. But if you need to build some non-trivial business logic around that, Nginx configuration language is not the thing you want to be writing it in. So sometimes you do want to put that tiny bit of business logic in there. For example, if you want to do an LDAP path and then query a Postgres server in order to determine where in the upstream you need to forward your HTTP request, you could do that by building a completely separate web app with all of its bells and whistles, but it's a bit of an overkill. You could also try putting that into your existing web application. However, it might not fit your architecture, it might not fit your programming model of choice, etc. So, for example, this is something that you might want to do with the Nginx modules. The second thing is you might want to add just a little bit of sprinkle to your HTTP requests before forwarding them to upstream. You might add some additional headers that depend on some complex business logic, which is a fairly standard thing for you to expect to do on a web server. You can also change the wire transfer format. For example, maybe you have something behind Nginx that doesn't speak plain text HTTP, and you just might want to change the wire transfer format. So we come to the central question of this talk, which is what if we could do some of these things in a language that's not the Nginx configuration language? What if we could script these Nginx modules differently? Let's put that aside for a little bit and let's talk about Lua. Lua is a really nice, small, dynamic programming language with incredibly clear semantics and a minimum of 2 amazing implementations. Lua was built pretty far back. It's not entirely unlike JavaScript, but when it was originally conceived, it was meant to compete with Scheme and a neat little language called Tickle. Lua is written in ANSI C, which means that you can use Lua on any system that has an ANSI C compliant compiler, which is basically any system in existence. And Lua is built to be embeddable. You can easily include Lua in your existing C and C++ applications, and you can use the beautiful Lua API, which is very clear, very explicit, to allow your users to script your applications. And Lua has what is arguably the best dynamic language just-in-time compiler in the world. Luajit has been in maintenance mode for a while now. The benchmarks are still on its side, and even if you don't believe a word I'm saying right now, which you shouldn't, it's a true engineering marvel. And if you don't take anything from this talk, you should definitely look into Luajit because it's freaking awesome. It's incredibly performant, it competes with native code, and really, really good optimizing compilers. So this is just a tiny example of Lua, so you can get the feeling for the language if you've never seen it. This is a really trivial factorial function, which isn't very exciting. And this is a little bit less trivial function that I stole from programming in Lua, which demonstrates some interesting features of the language that are not obvious, like the module system and first-class functions. So we do know that Lua is embeddable in C applications, and we do know that Nginx is built using C. So I think the question kind of poses itself. What if, right? Luckily for all of us here, far more competent people than I have come to this very unobvious and brilliant conclusion and wrote what is called Nginx HTTP Lua module. And this module allows you to script the Nginx worker process in various phases of its execution cycle. The 2 that we will be dealing with mostly are content by Lua and balancer by Lua because they're the most tangible, but all of the other ones are fairly useful and well documented. So let's say that you've been tasked with an incredibly important business assignment, and that is to come up with an HTTP endpoint /brew that does one of 3 things. If it detects the words coffee or beer in the incoming HTTP request, it will respond with HTTP status code 418, I'm a teapot. If it detects the word tea in the incoming HTTP request, it will respond with HTTP 200 OK, and in all other cases, it will respond with HTTP 400 bad request. Everyone had to do this at some point in their life. So you would start with a fairly simple Nginx configuration file like this, and the only differentiating point is the content by Lua block, which allows you to execute arbitrary Lua code in order to respond to this HTTP request. And your arbitrary Lua code would probably look something like this. You would read the request body, you would search for some keywords within it, and you would return the relevant status code. Bam. So let's say you've been tasked with another far less important and far less exciting task of actually determining the upstream server where you need to forward your HTTP request via some keys that are stored in a Redis data store. So you could start with a fairly simple Nginx configuration file like in the last part, and you could define your upstream server with a fake IP address and use the balancer by Lua block in there to execute arbitrary Lua code in order to set the upstream peer to which Nginx should forward the HTTP request. And again, your Lua code might look somehow like this. So you need to connect to your Redis instance, you need to fetch the keys, and you need to set the upstream peer to the host and the port that you fetched from the Redis instance. So this code looks fairly synchronous. You can't tell that this code executes asynchronously in any way, shape, or form. However, using the magic of the Nginx API and some fairly ingenious inventions by the authors of Nginx HTTP Lua module, all of the Nginx and REST APIs that you've seen on the previous few slides are asynchronous. And that is very important because your Nginx worker process handles your incoming HTTP requests, And if your Redis server is in China or simply down, you don't want your Nginx worker process blocked while it's waiting for the response. You want it to accept other HTTP requests and simply wait to see whether this will ever resolve or not. So the Nginx and REST APIs allow you to do that in a synchronous fashion in true Nginx spirit. So I hope you're somewhat intrigued by now. But Nginx HTTP Lua module is not distributed with Nginx out of the box. That's why people made OpenResty. OpenResty is a software bundle that contains Nginx, LuaJIT, and a bunch of libraries that allow you to do stuff that we've talked about in an asynchronous fashion. They have packages for a lot of major operating systems, and OpenResty has been used by the likes of Tumblr, Alibaba, and probably most notably Cloudflare. Cloudflare has been a major sponsor of OpenResty development, and until fairly recently, they have used OpenResty for a lot of their load balancing needs. They have since moved on because apparently Cloudflare is the internet today, but they've put in a lot of money into this. So since the Nginx HTTP Lua module is a fairly central part of this whole ecosystem, you will oftentimes hear these two words, OpenResty and the Nginx HTTP Lua module, used interchangeably. Don't let that confuse you. I'll do that until the end of the talk, probably. So depending on your ops practices, you may or may not want to build all of this yourself. It's not that trivial. It's doable. 100% of my exposure to OpenResty, to Nginx HTTP Lua module was through OpenResty, and that seems to be the preferred way of doing things, so your mileage may vary. So we come to the part of the talk where we try to do something less trivial. I won't have any more demos, and I'm afraid, but I will talk about how to do that in very general terms. So I do hope that keeping your business logic in Nginx configuration files doesn't sound like a good idea to any member of this audience. And fortunately, OpenResty allows us to load Lua code from files on the file system in order to execute the response handlers and that we've seen earlier. So instead of content by Lua block, you would use content by Lua file, and then you could use your entire Lua infrastructure to structure your code. You can separate your code into modules, etc. Since we have a fairly standard Lua runtime running in Nginx, Lua Rocks is fair game. You can fetch third-party packages from Lua Rocks and use them from your code normally. For testing, you can use Busted to unit test your Lua code like you normally would. And you can also use test Nginx socket, which is a Perl module written by the author of OpenResty, which allows you to embed your Nginx configuration file, your HTTP request, and your response in this unholy amalgamation of a file that could only be thought of by Perl developers. And then it will load an Nginx instance, it will run the HTTP request, and it will assert the equality between the two responses. It works really well, and it's really awesome. And since we've been talking about asynchronicity and performance, it's very important to profile your HTTP or your Nginx worker processes. And again, the author of OpenResty has a set of system tab-based scripts that allow you to generate those really neat flame graphs, both on CPU flame graphs and off CPU flame graphs. And if you've been at the tracing lecture yesterday, you could have seen a few things about that. So, what's not to like? It's not all roses. So, the first thing that many people notice when diving into Lua, whether from OpenResty or from game development or wherever, is the fragmentation of the Lua ecosystem. So there are two big implementations, LuaJIT and PUC Lua, and they have diverged somewhere around version 5.2. Now, operationally, that isn't that big of a problem because the vast majority of people are focused on LuaJIT because of its insane performance. And most library authors still target the least common denominator between the two languages. However, it's unclear whether that will continue for forever. And the other thing, which is far less trivial, is that it's not easy being asynchronous. Even on platforms that have asynchronicity by default, like Go and Node.js, it's not always easy to guarantee non-blocking behavior in your code. And this is even more prominent in Lua, because Lua isn't asynchronous by default. You have very, very synchronous blocking libraries out there. The solution to this, unfortunately, isn't very exciting. It's either to use the modules from the OpenResty ecosystem to do your work, or if you cannot do that because they don't exist or don't work, then you can get your hands dirty with C and use the Nginx APIs to implement these yourselves. Of course, that may or may not be viable depending on how familiar you are with C. So this brings us to what could comfortably be an alternate title for this talk, and that is that OpenResty allows you to configure your web server in a Turing-complete programming language. Now, this is a really neat thing on its own, but OpenResty does so with a really comfortable-to-use programming language with very clear semantics, insanely performant implementations, and just a comfortable ecosystem to work with. Now, in theory, you could build your entire web application using OpenResty. People have done that. The performance is insane, and it works fairly well. In practice, it will heavily depend on how much you want to invest in the ecosystem and the availability of asynchronous libraries for the thing you want to do. However, if you do have a problem that fits nicely into the asynchronous event-driven architecture that Nginx offers to you, I do hope that you will consider giving OpenResty and Nginx a shot, and I do hope that I've managed to convince you that it's well worth the trouble. So that concludes my talk. We'll be able to go to lunch sooner. Thank you. Rate my talk on Jointin. Tell me what was good, what wasn't, and I'm here for any questions. Thank you.
Time for questions. Lunch still doesn't start for another 7 minutes, so let's hear those questions. I'll start off with one while I'm walking over. Oops, sorry. Since I can have like a bunch of custom code in there, what prevents Nginx from becoming the next Emacs bloatware? I don't even need like anything else. I can just program everything right here in Nginx, right?
You could program everything in Nginx, but the point is that it's, this all simply builds upon the very natural extension of Nginx's architecture and simply allows you to do some things additionally that the authors initially didn't. I mean, you have modules for everything. You have modules for LDAP. So, yeah.
So this sounds like it goes way off the beaten path of like ship everything in Python or Node or Go and so on. So it's probably a lot more difficult to hire people for that and so on. So can you give some hard numbers on the benefits in terms of performance that would outweigh the complications of hiring for that and building that and so on?
So yeah, it's very off the beaten path. It's not unheard of. It's very unstandard though. So I don't have any hard numbers that I can pull out of my sleeve right now, but I think that some of the references that OpenResty has are fairly impressive. So Cloudflare really did use OpenResty for their load balancing needs. So whenever you configure your website in the Cloudflare control panel, once you configure it, it went through OpenResty. So they had a bunch of their actually caching and distributing business logic written in Lua and using OpenResty. Actually written in C mostly, but using OpenResty. So one thing I can tell you is that LuaJIT performance, which is kind of sort of the most important thing in an asynchronous environment, is insanely fast. It really competes with GCC and Clang and LLVM in terms of raw performance. It used to beat V8 by a factor. Now, of course, Google's engineers have been hard at work. It's not that obvious anymore, but it's really, really good.
Question over here on your left.
Hi. So, so if you had a system where you could auto-scale this for like CPU-bound task where it's not practical to be asynchronous and you still need to add more machines, so I guess adding some kind of a back pressure system to notify that you need to spin up more workers could be a viable thing where you can actually write all of or most of your business logic app in this language and then just use it for everything.
Yeah, of course. So the good thing about all of this is that you have access to the standard Nginx measurement tools. So you can use all of the tools that you usually use to scale your web server, if you do use Nginx, of course, to simply scale your application, because your application travels with your web server. So wherever you spin up a new Nginx instance, you have your web application for free, assuming you've configured it correctly. So that's a fairly neat thing you could do, yeah.